Good morning, all. Our session will commence in 5 minutes. Good morning, all. Welcome to 6-day FDP on emerging trends in GIS and artificial intelligence for civil engineering. Today is the sixth day and final day of our FDP, and our first session is Generative AI and Machine Learning for Modern Construction Practices by Dr. Harikrishnan PM. Dr. Harikrishnan PM is a distinguished senior research professional and accomplished AI innovator with over 7 years of experience bridging the gap between academic research and industrial application. Holding a PhD in computer vision and deep learning from NIT Trichypilli, he has evolved into a leading figure in the domain of multimodal generative AI, large language models, document AI, and agentic workflows. Dr. Harikrishnan currently serves as a senior research scientist at Quantify Analytics, where he spearheads applied research innovatives in multimodal document intelligence and agentic AI. Unlike traditional data science roles, his current work focuses on building agentic systems AI that can autonomously plan and execute complex workflows. His career reflects a mastery of full AI lifecycle from designing novel algorithms to deploying robust API in production environment. His research excellence is recognized globally with a transition from journal publication to acceptance at the world's most prestigious AI conferences. His research accepted at ACM MM 2025, CVPR 2025, and ICDAR 2025. He has he has authored impactful papers in SCI index journals such as Applied Intelligence, Biomedical Signal Processing and Control, and IEEE Sensor journals. Let us extend a warm welcome to Dr. Harikrishnan and invite him to share his expertise with us. Sir,
You, Anu ma'am, for that wonderful introduction, and thank you, Department of Civil Engineering, Sripati Engineering College, for inviting me to have a discussion with esteemed faculty members of different engineering colleges. Let me know if my screen is visible. I'll start sharing my tab. Right. You can see my screen now.
it's okay, sir.
Yeah. Okay. We'll be discussing today somewhat certain things will overlap with what we discussed on the day one, uh, right? The generative AI and agentic AI concepts and its applications for infrastructure, mobility, etc. So here, construction specifically, and mostly it may come under even the infrastructure development also. But what we will be focusing today is all about how this progress in the space in the modern construction research in this space, how it is evolving from traditional machine learning from classification and regression approaches, which most of you know, to generative AI and other approaches. How you can bridge, how you can combine all those methods together to make sure you use maximum usage of the AI solutions to accelerate the productivity. Right. So, having said that, uh, we will be discussing about how AI is transform civil engineering, especially the construction area, from traditional predictive modeling to intelligent content generation, structural synthesis, and optimization for better construction infrastructure. Right. Having said that, why do we need AI for a construction field? Which is the fundamental question maybe people may ask, right? Why should I do uh, construction management enabled with an AI technologies? What benefit I'm going to get if AI is involved in the construction area? Because everywhere, every field you can have nowadays, people bring unwantedly or unnecessarily the AI concepts, but it is our duty to know that, okay, why should I learn, or why should I have in my domain, my area, the application of AI, right? So when it specifically comes to construction, what is the need for AI, right? Will so you will be knowing these bottlenecks and these issues better than me, because you, as civil engineering faculty members, professors, you are the one who knows better about the challenges in construction area. Right? So effectively mitigating recurring cost overruns, safety incidents, and schedule delays. This is what always, even if you are constructing individual house itself, you know how it starts with a budget and how it's end at whatever is the reality. It, they may have given you an estimate of X lakhs rupees, and for this many months they will complete, but most of the time that doesn't match or doesn't meet the expectations, right? So there are several reasons due because of that. The cost is overrunning. There are always schedule delays, and of course there are some safety problems also happening. And modern sites generate massive unstructured data, right? So when you consider larger construction of buildings, bridges, etc., there could be uh, CCTVs installed there. There could be telemetry systems there. Then, of course, there will be lidar systems uh, to create the 3D structure of the buildings and this what was the structure you're constructing. Then, of course, nowadays people use a lot of drones to continuously monitor the construction field. So these all create a lot and lots of data, which if you don't really use effectively, it's going to be a waste. Rather, if you use it effectively, it's going to give you so much insights during the construction of that particular field and even beyond. You will it will help you to uh, do a next construction site in a better way. And as we said, more data is not going to help you. How you interpret that more and more data is the one which decides how well you're utilizing or how well you're utilizing an AI, right? So the right side one, which you simply see is uh, a simple image of from a building wall. How do you identify a crack? Traditional approaches use, uh, say, usual object detection using convolutional neural networks and gives you a bounding box. One second. Sorry. Right now, coming to you now, you know why we need not just in construction, any civil domain, any civil engineering area. What is the application of why do I need to know AI? It is obviously to reduce the unwanted cost, reduce the unwanted delays and latencies comes in between, and of course to reduce or to make the field, construction field or infrastructure development field more safer, less accident incidents, etc. So AI can bring all these things in a better fashion. Now, when you say AI, it's not ChatGPT, it's not Gemini alone. Because nowadays people think of uh, for non-domain people, AI means Gemini or ChatGPT. But we should not say that. At least even you, whoever is listening to this, should not say that because you will be. Everybody would have used regression modeling. You would have used linear regression, multilinear regression, at least for many of your civil engineering related projects. So that is also an AI. A simple linear regression model is an AI model that does a statistical analysis and gives you certain predictions that a human may take so long to do. That's an AI, artificial intelligence capability. So that's where it started. Say the era is like role-based systems, which are mostly deterministic logics like expert systems, if-else statements. If this is the condition, do this. Else, if this is the condition, do this. So that's a fixed, rigid, rule-based mechanisms. That itself is an AI. That's where AI started. Then classical machine learning approaches, which you all know, that's prediction and regression and classification models, right? Linear regression models, support vector machines, random forest, support vector regression models, etc. And then is where deep learning started, artificial neural networks, convolutional neural networks, which is mostly became so powerful where it can actually see or there is a visual perception behind it. That's where deep learning meaning it's not just convolutional neural networks, but artificial neural networks without image as an input. But mostly the convolutional neural networks is what really helps in the construction area because it can monitor the camera footages, video footages, and it can identify uh, safety violations, it can identify cracks, it can identify number of people working in it. So it's mostly related to image classification, object detection, image segmentation, etc. And the where popular models are convolution neural networks, YOLO models, UNet models, etc. So from there is what the evolution is from 2020 onwards, maybe. Generative AI is where it's not just interpreting the input image or input Excel sheet. Rather, it is generating based on your input something new, right? So you all know, definitely you will know about BIM, right? Building information mapping. I'm not exactly very sure the full form, but that is what creates the 3D structures of what you're going to construct, whether it is a bridge or a building or a or whatever you are constructing, you can create using Revit and other very popular frameworks or tools. You can create the 3Ds, right? Now with generative AI based latest models, you don't need to be a Revit expert to create 3D models. As you use Gemini or ChatGPT, in the recent time, you will see in all your 3D design, CAD design tools, uh, instead of you manually go and do these things in that software, which requires domain expert specifically. Rather, you will see a chat space there. You just need to input your requirement in natural language or audio descriptions. Then you will see the 3D design, you will see the CAD design, everything populates. And you will be again talking to the agent or talking to the generative AI model behind that whole software to refine it better. You can create 3D designs, you can create CAD designs, you can create floor plans, you can create interior decorations. Everything is possible with the generative AI approach. So that's where the whole landscape is changing. And it comes to construction, as we said, you have to pay a lot for these software tools like Revit and other BIM tools or BIM tools to create perfect 3D structures. But that thing will change now because with latest generative AI and the agentic AI based models, uh, it's going to be more democratized in such a way that even a non-civil engineering person, like a contractor, uh, like a mason itself, if they are if they are having a mobile phone, if they know what is the 3D they want to create or what is the building they want to create, if they know the details, it's easy for them also to create 3D structures with latest advancements in the generative AI space. So that's where the evolution has started, just from saying, okay, do this, if this happens, do this with expert if else statements, to just predicting, say, the building load using all other parameters, or the soil conditions using several other parameters just as a regression model, to isolating or detecting damages, or cracks or people during in the construction site with convolutional neural networks based deep learning models, to where we stand now is you can even synthesize, you can even reason out, which I discussed last class, right? Using the VLMs or vision language based models. That's a part of generative AI. You are no longer just detecting, you're thinking like a human and interpreting why that damage happened, how can I resolve it, and it's you can even create, okay, in order to resolve it, how can I create a better 3D design. Everything is possible with the generative AI. So it's a entirely completely landscape change. Now if since our topic itself is machine learning and generative AI, I'll be quickly talking about uh, classical classification or classical AI specifically for our construction field. So this you would have done or will be doing even it in your labs also, I guess. So assigning geotechnical parameters into discrete predefined engineering categories. So it's a classification, as in soil profiling. If you do automatically identifying the different types of soil from your CPT test soundings, right? It's you will have so many parameters in the corn penetration test. Those parameters you need to map into three categories, like whether it is a clay soil, silt, or sand strata. It's a very traditional classification approach. You may have an Excel sheet. Then you Excel sheet you will have X number of columns that represents all your input sounding parameters from CPT test. And then for each of those row items, you will define uh, a specific soil type, right? So what it does, it does make the QC quality check workflows into a standardized format, streamlining batch inspection by mapping material inputs directly to pass or fail structural standards. So rather than a human manually does all these things based on the historical data, it's very easy and very accurate to create a classification model. Now, predictive equipment maintenance. So input telemetry monitors engine temperature. So telemetry applications that is again involved with traditional AI that checks the engine temperature trends, hydraulic vibration profiles, fuel rates, and oil pressures in real time. It is to basically monitor in construction fields. You will have large machines, large vehicles, large equipments working. So it can continuously monitor the behaviors of each of them and report it to the engineer or the operator who works on that. That is uh, the basic thing that's happening with telemetry. Again, it can only report the live values. There is nothing beyond reporting. It cannot take any action or it cannot create any insights. That's where generative AI and agentic AI comes into place. On top of telemetry data, if you continuously have a agentic AI model or agents on top of it, it can monitor all these details. It can proactively say that, okay, in next 2 days, the fuel is going to end. You do this so that the fuel can be saved, etc. And we know random forest models, again, similar to other classification models, random forest can be used as a classification model to classify your assets into healthy, minor invention required, or critical failure, like during a construction site. So this actually eliminates the additional construction works by shifting site mechanics from reactive repair to scheduled predictive replacement. Now, same way, soil classification also, uh, the traditional civil engineering method, it's manual. Using an ML classification approach like an SVM, you can do the classification even really better way of classification of the soil uh, testing, and it generates automated soil maps, and it drastically reduces the laboratory turnaround. As in, instead of doing this in a physical lab, we are not saying that you should not do it in physical lab, but even before doing this in physical lab, which takes a lot of time, using historical data and the current field data, you could have leveraged SVM like classification models using the soil data. It's always possible to get 95 to 97 percentage accuracy in the soil classification. And if there also you feel problems, then you go for a actual soil test. And same way, say concrete strength prediction also. We know that you have a specific mechanism to test the concrete strength. There are certain lab tests you need to carry out for X number of days. But is it possible to do the same, or is it possible to get the similar level of uh, correctness using machine learning algorithms? Yeah, research says, or it has even proved many years back, right? Regression models are good enough. So instead of doing it for that 28 days manual test, these algorithms can map water, cement ratios, fly ash percentage, and many other parameters and into a performance, or into a prediction strength, how strong your created concrete in maybe in a day. So that 28 days has come down to 1 day because it considers several other factors, right? Now, what are the limitations? I think you, in several projects, many of civil engineering faculty members and professors would have done at least various classical regression classification models. But is it enough or is it sufficient uh, to make use of maximum data out of a construction site or construction related field? So, as we know, always classical ML models like classifier and regressor works with handcrafted, human created or human derived features. So if the features are not enough, if the features are too biased, uh, the whole prediction is going to be wrong. It entirely depends on how you, as a domain expert, identifies the features. So if a specific feature, if an engineer forgot to add, the model fails. And it entirely depends on the human cognitive workload or cognitive bottlenecks. And you cannot process unstructured data, which is the large number, right? The structured data you use to train a linear regression model is a tabular data, but that is not the one which actually originates from a construction field. You don't get from a construction field tabular data. What you get from construction field is images, drone surveillance cameras, camera footages, uh, and several other things which are entirely unstructured. Using classical models, you cannot leverage those informations to effectively monitor a construction site. That's what we call it as the threat of unstructured data, which you cannot process it with traditional ML models in scale. That's where the deep learning evolution came. Automatic features. You are not deriving. This is the biggest difference between traditional ML and deep learning, right? In traditional ML, as we said, you are supposed to create the features using feature identification methods, feature selection methods. You are supposed to derive the features and then use those features to train the regression models. But which is again entirely a human dependent biased issue. With the moment it shifted to deep learning, there's nothing like you curate the features. Rather, the deep learning models learns the features what it requires for a specific task. So it's an automatic feature detection and feature selection methods. It identifies the patterns based on your data. And more importantly, it has spatial convolutions which can go through images, videos, and visual inputs and clearly identify patterns in images, and it can automatically inspect things and unlock continuous real-time visual tracking, identify safety violations, cracks in the road, cracks in the buildings, and PPE usage, counting the number of workers in the site, etc. So the important thing is, from machine learning to deep learning is the model itself or the algorithm itself identify the best feature patterns from your data. Now, examples: automatic crack detection from buildings, a real-time PPE compliance using the most important model or most efficient model people use for PPE detection in construction sites using either drone footages or surveillance cameras is YOLO models, which is you only look once, which is a very, very popular deep learning object detection model that can even get deployed in a normal consumer mobile phone, and it can do this tasks really faster. And maybe you are seeing these sort of models in your mobile phone also in filters, etc. You see bounding boxes on your face. A group of people, if you take photographs, there is face detection models. These all are deep learning models that can be deployed in an edge device. And say it depends on um, the violations. It can show various colors of bounding boxes. Say if somebody is not wearing a helmet, it can plot a red bounding box across that person so that it gives you some actionable output, such that as a civil engineer, site engineer, you can manually go and inform that person to actually come down from that site and wear the proper PPE compliance, right? Another example is drone-based site surveys. Again, continuous georeference photogrammetry. The automated flight tracks compile high-resolution georeference photographs. So, as we said, using drones or other mechanisms, if it's a larger construction site, it's always possible to get the footages. Then using those footages, you can create uh, 3D design from so many 2D images. That's how 3D is created, right? You can create 3D structures using deep learning models. Yes. Similarly goes for BIM tools. I don't know how many of you are aware that okay, BIM, building information modeling tools and frameworks, they are actually using deep learning models inside, computer vision models inside. Also, what you can do is say before you actually create 3D BIM modeling before you start the construction of the site, right? Now, using computer vision mechanisms, what you can do is you can entirely cross check while you construct the site using the construction footages from drones. You can align and see, okay, is the 3D which I planned aligned with the 3D cloud points that I can get from surveillance cameras or drone images. So that clearly helps you during each stages of your construction how well or how similar what you construct is from the designed 3D structure. And that actually reduces a lot of money for the contractor in such a way that the progression payouts is based on the physically completed AI verified structure rather than uh, I have seen or I have heard many scenarios where the 3D created before construction and the one which they constructed does not match, and there will be so many uh, changes people make. So that involves a lot of money and time, which can be reduced with effective utilization of drone footages and converting that into 3D cloud points and checking that against your BIM 3D model. Yeah. Now we have talked about traditional ML in construction, how convolutional neural network can enhance them or how deep learning can enhance them. Now, is it sufficient? Can we have something better or some more better AI technologies to further enhance the utilization of AI in the construction field? That's where the generation or generative AI comes into place, right? Classification or prediction models until recently, this is the real point. Until recently, consider it as the AI, so-called AI, like classification models, classical ML models, deep learning models, are just behaving like an inspector or an analyst. It answers retrospective question: what is this crack? Or when will this scrap excavator pump fail? This still leaves the core structural design loop manual and slow, right? It only observes existing structure and data, and it forecasts likely component outcomes. Based on historical data, using ML models or deep learning models, you can just predict certain things that may appear in the future. Or you can say, this is this, this is that. You cannot do anything beyond. But the moment you switch from traditional AI, ML, deep learning to generative AI shift, so it's something like this. It actively creates engineering assets. Instead of analyzing uh, normal form, say drawn forms, it synthesizes new structural topologies, generate functional BIM elements, drafts construction schedules, and builds risk mitigations. As in, when a discussion starts itself using generative AI methods, you can entirely create the floor plans, 3D designs, maybe the used based on the size of the construction field, based on the number of employees they may deploy, etc. It can entirely create a schedule of work so that the contractor and engineers can plan it very well. And it can also mitigate, and it can also think of the risk failures that can happen across the duration of the construction, and it can also suggest you the mitigation strategies to effectively handle those problems. So it can easily synthesize lightweight civil engineering designs very faster, and it can create every day to day whatever happens on the site. Based on that, it can create reports for the contractor and the civil engineers that may involve cost aspects, risk aspects, time delay aspects, and everything. So it's moving from just what is happening and what will happen as a prediction to entirely generation based system monitoring, generation based report creation, etc. Now, again, a few examples. The moment you generative switch to generative AI, right? When it comes to generative AI, before LLMs or vision language models, what started as a generative AI model was variational autoencoders, but the one which started very popular is something called as generative adversarial networks, GANs. So, and then started something called as diffusion models, which is again a generative AI vision models. So, using certain diffusion models, uh, again within the space of construction itself, there are construct, diffuse, and several other models which I have seen. They can do something like replaces manual CAD design trials, algorithms synthesize thousands of balanced alternatives. As in, instead of using paid or very complex CAD, you can leverage a diffusion model that can create you several various designs, structural designs of a particular construction site or construction component you are going to create. And these models can mathematically curve away unused structural volume, focusing steel only along verified stress paths. So, I don't want to go into very details of civil aspects here, and integrates finite element structural constraints into generative loops to meet code limits. So again, these models are trained with a lot of design patterns, structural design, so they can affect they know the do's and don'ts of a design. Based on that, it can suggest you and create you various designs from which you can easily pick a design. Now, AI assisted BIM generation, spatial layout input takes. So we know that BIM is a paid tool. Many BIM tools are there, but what it is enables a BIM to become more effective is if there is an AI, a diffusion model or a generative vision language model behind a BIM tool, what happens is it can, using your human inputs, your other floor plans, or maybe other different constraints as an engineer you provide, maybe as documents or as your natural inputs. AI enabled systems can map those things into very rich 3D designs or 3D point designs rather than just leveraging the BIM tool as it is, right? So the third point is evaluates prompts like synthesize an academic block flow following structural safety regulations and concrete codes. So as I said, rather than using the tool as a domain expert, use the tool with natural interactions. Still, you will get better 3D designs using the paid BIM tools. And I am not very sure whether currently any of the BIM tool has an AI assistant, but in the near future, you will see those assistants comes in place. Now, very importantly, another aspect of uh, generative AI in the construction field or manufacturing field, wherever it is you can leverage them to create more and more synthetic data, right? Say you are still working with a deep learning model. Your objective is to uh, have a small YOLO model, object detection model, to just identify PPE compliance in a site. You want to detect is every employee wearing a helmet, wearing a jacket, having shoes, etc. Now, you in order to identify that, you need both scenarios: people wearing helmet, people not wearing helmet, people wearing jackets, not wearing jackets, people standing maybe on the roof, maybe standing maybe at the floor. Various scenarios you need, and it is very hard to get all these scenarios from the real field video footages, right? It's not possible. Maybe assume you have a very compliant field where people will be always wearing these. So if you take only those footages, you will not have enough data to train a model what is non-compliant. That is a scenario for every field, right? Always it is a there is a bias between two categories of data you need. You will have ideal scenarios a lot, but you will not have the non-ideal worst scenarios. And it was a very hard problem for traditional ML and deep learning methods. Your data will be always biased. So 70% of the data is with the helmet, 30% is without helmet. Now, how will you train a classifier models to do with and without helmet detection? It will be always 70 versus 30, right? So people used to do upsampling or downsampling in the earlier days, but that either lose a lot of samples or it adds a lot of noise. Now with generative AI approach, what you can do is you can use generative AI models to create scenarios. You can uplift that 30% of no helmet scenarios to 70% by creating synthetic photos, synthetic videos, synthetic scenarios, which can be used to train that smaller models, which you can finally use it in your construction site. If it is just a PPE detection, you don't need to actually leverage or actually deploy an entire vision language model, right? You just need an object detection model inside your camera and it can continuously monitor your site. But in order to train that model, you need data. That data you can use generative AI models like diffusion models or vision language models to create, because it can create very realistic uh, synthetic images that can replicate cracks, corrosion, safety violations, etc. And that data can be easily used to train your model very well. And synthetic data generation is one of the area where I am actively working on in my current company across domains. Uh, the the need of synthetic data is increasingly and rapidly exponentially increasing, because everybody has seen the power of generative AI models now. So they know that without actually using the real customer data or real human data or real field data, I can still generate similar data using AI, and I can leverage those data either to train my own models so that there is no human data involved for training, there is no compliant issues, or I can test my existing pipelines, existing models, etc., using again synthetic data without pushing human involved real data to the system. So synthetic data generation is a particular area where everybody based on your domain, is if it is construction, if it is infrastructure development, if it is transportation, everywhere synthetic data generation can be a topic of research to pick up. And there is a lot of things to do in this particular area. Right now, uh, moving beyond just generation, if you use large language models and multimodal large language models, you can actually leverage them for perfect project scheduling, right? Unstructured LLMs parse through decades of legacy construction logs, change orders, archives, and site notes. Uh, Before you start your project, if you if you have your historical project details, if you have the historical details of the land where you're constructing the things, and several other details if you have, it can very effectively, very critically and actively create a project plan that will be always helping you to reduce the cost, reduce the manpower, and reduce the latency involved in construction. Uh, Instead of a human directly thinking of the project scheduling, which will have lot of errors, but if AI is involved, it knows the whole historical data, and the project schedule it creates will be better, so that the engineers and other people can verify it, and that will eventually reduce the risk. Now, key deployment challenges, right? We were talking about generative AI, how it can help construction and how it can enhance the usage of AI rather than traditional models, or how you can together use traditional models with AI. As we said, use the generative AI for synthetic data generation, then use that data to train a traditional small model for your specific use case, which is going to be the real use cases people may do, because generative AI are these models are very heavy, or these models are very big. Either you need to pay for it, or you need to have high infrastructure to host these models. So if your task is very specific, like soil data classification using soil images, you don't need a Gemini to do that. What you can do is you can use either Gemini or ChatGPT or several any of the generative AI models to create images, various soil condition images, then train a small classifier deep learning model and use that model, which is not going to cost you anything. So that's an ideal scenario. You can leverage both generative AI technologies and traditional AI technologies, right? So the biggest practical challenge leveraging, uh, especially generative AI, is uh, models may hallucinate a lot, which we discussed last class also. Generative AI, the biggest problem is hallucinations. So how you mitigate is physics-informed neural networks and boundary tests. This is one of the things that people use, especially on construction, manufacturing, and other fields. It's called PIN. Uh, Physics-informed neural networks can really help to reduce the way models hallucinate. Then explainable AI and other aspects can be introduced to explain the terms and terminologies and generative AI says. Say, if a generative AI model, a Gemini says there is a pile foundation failure, how do you trust that prediction? So for that, you can use mapping, explainable AI mapping models like SHAP and Line, and then generation that violates design rules. Like we said, Gemini or ChatGPT are more biased, maybe more biased towards Western, because they are originated, they are more training data is from Western US related things. It may not be knowing the Indian standards and other things very well, and it may violate while creating designs. It may violate Indian rules. So how do you mitigate that? Which we again discussed last class using something called as RAG, retrieval augmented generation. You keep all the Indian context, documents, design rules, guidelines, etc., and ask the model to refer to only those when it designs certain things for you, or it generates certain documents or certain images, certain scenarios for you. Now, uh, so the future intelligence in construction area or manufacturing area is you use it's I my whole purpose point is to say that you will not use traditional models. No, you should use traditional models wherever it is applicable. It should be a hybrid mechanisms where you leverage the strengths of each of the AI technology. So obviously, if you have tabular data, always the historical tabular data, and your purpose is to do a regression modeling, you don't need again a Gemini to access your tabular data and do a lot of interpretations. But you use regression models, SVR, random forest, linear regression models to predict the physical strength and parameters if your whole objective is to predict from historical data. Now, as I said, if your objective is only to visually perceive things, go for convolutional neural networks and YOLO models to detect damages, to detect structural instabilities. That's only perceiving. Now, if your requirement is generating content uh, for 3D design generations, structural image generations, etc., you cannot use that with predictive models or CNN models. You need generative AI models like diffusion models. That's what something TopoGAN and TopoDiffuse and GANs, etc., which can generate you the images. Now, on top of all these things, you want to take actions, you want to make sure it analyzes the data across projects, it analyzes the years of data to give you best construction practices. It can give it if you want to create an entire schedule, if you want to see the 3D designs aligns with the actual construction going on, like you want to do the holistic end-to-end things. That is where it comes to generative AI into agentic AI space, where these systems can automatically plan, act, observe what is happening, and communicate with the user and get the feedback from the user and do things accordingly. So that's where reason and act comes into place. Autonomous agents monitor telemetry. One example it was mentioning, like the telemetry data of a large equipment in a construction site. It continuously monitor that data, and at a point it feels that okay, if at this pace, if the system works, the temperature may rise to more than reference range in another 2 hours. If that happens, there's a high chance that an explosion happen. So that I need to reduce the consumption or reduce the temperature of the system, or I need to switch off a certain aspect of the machine such that the temperature will come down. And it informs the operator that such that a proactive action is taken based on the past history or current real data rather than just reactive. Right. I guess this is what I have for the day, mostly about construction site. And any of these discussions or any of the points which we discuss is not just applicable to construction. It is applicable to every domain, not just on even civil engineering domain. Like people use regression models, classical machine learning models, deep learning models, then generative models in electrical design, say uh, PCB circuit design also people use it nowadays. So every domain it is applicable. I just push the examples, applications, use cases into construction such that whoever is working on uh, construction area, you still have a lot of opportunities in this field, and the best opportunity to leverage is a combination or a hybrid approach that involves traditional regression classification approaches and convolutional approaches to generative AI, and end it with the agentic AI concepts if you want to build an autonomous system that entirely handles the monitoring of your construction field. Yeah, having said that, I'm at the end of the session. Maybe I'll be happy to take any questions the audience have. Uh, yes. Anumol, Miss, I'm done from my end as the session.
Hello, sir. Hello.
Yeah, yeah, I can hear you, sir. Yes.
Okay, the session is over. So it's a time for Q&A. Any participants who would like to discuss anything regarding today's session, you can ask. I will be unmuting you all.
Mm. I think I'll take it as a no then.
Actually,
You can reach out to me for any clarifications required.
sir, actually, you said that we can use different models for the concession. Uh, so whether we can rely completely on these models, when we can rely, actually, according to you, in which year we can completely rely on generative AI models for almost 90% of the work.
It'll take time, as I said. Uh, for 3D design, maybe there are promising models out in the market, but it's all about those models are from some university or some labs. They have created it as a research solution or a prototype, right? Now, if you want to use it scalably, there should be some industry collaborator or some company which is taking up that and seeing its scalability aspects in a product aspect, right? So that's where the things come. Say people who build solutions like Revit, etc. They'll be investing a lot in generative AI, I'm sure. And the moment it lands as a product, that's where its scalability comes. Whatever I was discussing mostly is about the research aspects of it, referred from different research papers, white papers, etc. The moment it becomes usable, actually a field usable thing, it's when comes with a product which is already there out or comes as a new product. Maybe in another few years, you will see the change in the tools and technologies that you use. Right nowadays itself, think of I'm referring an example which is Canva. Right, Canva used to do designs, posters, etc. Now Canva can be, I don't know how many of you have used this. You can connect Canva in ChatGPT and you can just prompt in ChatGPT to design something by using the Canva connector. It will open a Canva design,
Yeah.
and you can open that Canva design in Canvas itself, and again come to ChatGPT and talk in natural language to edit it. The same way you will see in the near future, in couple of years, in almost all the uh, 3D designs, floor plans, interior design tools, CAD design tools, a chat space where you can give your inputs. Yeah, it will not take many years, maybe couple of years.
Okay, okay, sir.
Yeah.
Actually, Canva maybe an application that we are all are using.
Yeah.
Actually, I read. Uh, Actually, I don't know. I'm not sure about the. I'm not sure about that. But some experts say that they are saying that they are the development of AI is not that much that is expected. Well, that is expected before 10 years.
You're saying it's not progressing as
As
expected.
expected. Uh,
Is it
yeah.
in the any specific domain, or are you referring to a
In
specific
general,
domain?
actually, I don't know where I read that, but actually,
Maybe you would have read it opposite, as in it's progressing beyond what is expected. That
oh,
is what, at least in the uh, coding aspects, content creation aspects, human interaction aspects, it has evolved even beyond what people expect.
Okay, sir. Okay, sir.
Yeah. But coming into um, individual domains like, right, construction domains, civil domains, electrical domains, etc., that will take even more time because almost all the providers, AI developers now, their major focus is on first is code,
Yeah.
okay, code generation, then content generation. Uh, each individual other enterprise say core areas where it is still evolving. That's where I said it may take another 2 years or 3 years, 5 years. Depends on the core area which you're working on. Yeah.
Okay, sir. Okay, sir. Thank you. Thank you.
Yes.
Actually, I think there is no other questions. So let me
Yeah.
conclude. Let me conclude
Sure.
the session with a thank you note. So I'm taking a moment to uh, thank Dr. Harikrishnan PM, who is Senior Research Scientist, Quantify Analytics, Bangalore. Uh, on behalf of Department of Civil Engineering, Sripati Institute of Management and Technology, Vavanur, I extend our sincere gratitude to Dr. Harishan PM for delivering an insightful session. And we are very much thankful to you, sir, because you took 2 sessions for our FDP uh, by accepting our invitation. Thank you very much for the valuable inputs. Thank you, sir.
Yeah. Thank you so much for the entire civil engineering department for inviting me for 2 sessions. I'll be happy to have further collaborations and further interactions whenever you are required. Yeah, thank you.
Thank you, sir. Okay, dear participants, we will be sharing the feedback form in the WhatsApp group shortly. So thank you for joining the session. You can leave. Thank you. Thank you very much.